Hey everybody, this is Larry. This is day 19 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let's get started on add binary. Okay, given two binary strings, we return this sum also a binary string. The input strings are both non-empty and contain only characters 1 and 0. Okay. So I'm going to just assume a little bit that converting them to decimal or base 10 number and then adding them and then we converting back to binary. I guess we could do that, but that's really not in the spirit of things, I think. Yeah, I mean, that could be a one-liner. So I think what I'm going to do instead is just do it arithmetically. So I don't think there's anything tricky with this problem. I think you just do it how you would think to do it, right? Which is just to line them up like in grade school, one by one, or digit by digit, and then add them, keep track of zeros, and then go on. So that's what I'm going to do. And the first thing I'm going to do is just converting them to an array, just so that it's slightly easier to handle. But yeah, so I'm just calling them AN maybe, or A in A. For X and A, and then let's reverse this so that we get it in a good way. And then let's just do the same for B. And of course, if you're in an interview or something like that, definitely dry yourself. Don't repeat yourself and put that in a method. Maybe I'm just feeling a little bit lazy today, so I just went for a 5-mile run, so I'm a little bit sweaty. Cool. And then now, let's just have a let's just have an element. And I'm just thinking a little bit, what's the cleaner way in Python? Because I usually do this in another language, but I think okay, so I think I just do something like for index in range sub n, where n is equal to max of length of an and length of bn, and then let's have a carry bit. Okay, so that now for each index by index, let's just call them a bit is equal to an sub index, maybe. Or we could just go a bit is equal to 0 if index is less than length of a sub n, and we could cache the length function if we really want to. And same thing for b bit, if index is less than length of bn, b bit is equal to an or bn index. And then now the current bit is just equal to a bit plus b bit plus carry, right? And in this case, even if they're all ones, we can only carry one, so that's good. But yeah, so then now we just put this in the answer. Dot append current bit mod 2, yeah, and then now carry is equal to current bit divided by 2, right? Because you want to carry everything that's 2 and higher, and here's just the remainder. And we can actually use div mod. I should probably be more practice on that anyway. But yeah, that's mostly it, except for that if carry is greater than 0, then we append it one more time. And it can only be 1, right? So that's why we don't have to do any additional check. And then now we return, so now this is lowest bit first, so now we want to reverse it back and then just make it into a string. Okay, I guess there's only in 2 cases. Ooh, 1-time error, that's not great. I have a typo, that's all. Well, that's one of the or. We'll see if that's actually or. Been very sloppy these days. Not sure why. Cool. Some of these strings. Oh, I didn't map these to ints. Okay. And then now these are in, so we would have to map them back to strings. Maybe, we'll see. Yeah, okay. So yeah, let's just map these two strings. Cool. So that looks good. I think we have a couple of cases like 1 and then a lot of ones for a lot of carries. Just 0 and then maybe a lot of numbers. Doesn't really matter. And yeah, maybe that's okay. Oops. Just playing around with them. Looks okay. So let's submit it and sweet. So yeah, so it's cool. So I think this is just a practice of being careful and kind of going through the motions a little bit. Yeah, I mean, I don't know. I'm trying to think whether there's anything cool to learn from this. I mean, not really. I mean, these are very fundamental parts of big ints and definitely very useful. And conceptually, you could see if you can make some optimization here. Right now we do it bit by bit. Conceptually, you could do it, 32 bits at a time. See if you want to play around with that, if you want to upsolve. Overall, this is O of n, where n is the length of the longer of A or B. And that's going to be your output sensitive, so the space is going to be also that O of n. Yeah, that's all I have for today. Let me know what you think. Let me know how you did. And I will see you out tomorrow. Bye-bye.